Okay, this is an extension of the intro to the quadratic formula. So what I did was, first we want to make sure that we have our quadratic formula nearby so we can refer to it. And then for these problems, if you haven't done so already, try them out before, looking at anything. Just pause for a second. Okay. You definitely want to put them in standard form first and then identify your A, B, and C. So I've done that and I filled in the quadratic formula. So pause if you haven't done that and make sure you get to where I am. All right, so in the first one, remember it'll save you a lot of trouble if you simplify what's in radical symbol. So 25 minus 4 times 2 is 8, times 7 is 56. Okay, 25 minus 56 is negative 31. All right, so before I do anything else, can I take a square root of a negative number? No. So this one has no real solutions. Negative 8 plus or minus, let's find out what's in this radical. 64 plus, because negative times negative is a positive, 4 times 3. 12 times 12, 144. So 64 plus 144, 208. X equals 208 is divisible by 4, but is it divisible by anything? It's not a perfect square, so divided by 4 again. Okay, so 208 is divisible by 16. And so square root 16 times square root 13, which means we have negative 8 plus or minus 4 square root 13 over 6. All right, 8, 4, 6 are all divisible by 2. So my final answer would be x equals negative 4 plus or minus 2 square root 13 over 3. So no solutions was here. 2 solutions, because I've got negative 4 plus 2 square root 13 over 3 and negative 4 minus 2 square root 13 over 3. What's going on over here? X equals negative 12 plus or minus 144 minus 8 times 18. 144. So square root of 0. So that goes away, it doesn't matter. Negative 12 divided by negative 4. One solution. Okay, so I kind of tried to make a big deal out of what we're seeing inside the radical each time, because that has a special name and we call it the discriminant. Okay, wouldn't it be nice to know, before doing all the work, wouldn't it be nice to know if you're even going to have a solution at the end? Okay, so in the quadratic formula, the discriminant is the expression under the radical symbol. So it's the b squared minus 4ac part. And it tells us the type, real or not, and the number of solutions. So for instance, we're going to relate these to the graphs so that you can see what we're talking about. If we find the discriminant, b squared minus 4 times a times c, we get a negative number. And what we see here is that we don't have any solutions. We don't cross the x-axis. So when the discriminant is less than 0. We have 0 real solutions. Here our discriminant would be 10 squared minus 4 times 1 times 25. And what we see there is 100 minus 100 equals 0. So if my discriminant is 0, we would have 1 real solution. And you're going to see that when you have a perfect square trinomial equal to 0. And b squared minus 4ac. 49 minus 16, 33. When our discriminant value is greater than 0, we have 2 real solutions. Now, what's nice about the discriminant is sometimes that's all you need to know for a word problem. The function r equals negative 3p squared plus 150p plus 1,280 models the daily revenue for a company that makes scientific calculators, where r is the revenue and p is the price per calculator. Use the discriminant to show whether the company can make $4,000 per day. So that's revenue. So 4,000 equals 3p squared plus 150p plus 1,280. Minus 4,000 from both sides because we still have to have it equal to 0. Okay, so 0 equals negative 3p squared plus 150p minus 2,720. A, B, C. B squared minus 4 times negative 3 times negative 2,720. 150 squared is 22,500. And then negative times negative times negative, that's going to be negative. And let's plug this in the calculator. And we get, so my discriminant value is negative 10,140. So, can the company make $4,000 per day? No. Which, this is a lot less work than, say, using the whole formula to find out, hey, wasn't even going to happen. Okay? Now, you can find the value of the discriminant, and that tells you how many solutions you have. The value will tell you how many solutions. So less than 0, 0, and greater than 0 will matter. Okay, so you can do practice about the discriminant on IXL BB12. Okay, and the back of this page has quadratic formula practice with answers and discriminant practice with answers. Now, one really good question is, should you always use the quadratic formula? The answer is no. But I want you to think about that while you're using it. Is that your favorite method? Is it faster? Is it working for you? Does it work every time? Yes. But should you use it every time? No.